Oh, wait. Oh, so that's true that I screw up the link. The link you guys have is correct. The link that I have is wrong. Okay, sorry about that. Share the screen. Oops. Can someone go tell Honkamon and the gang in the other room? Oh, Honkamon is here. How does that happen? The link that I have on my calendar and on Canvas are not the same. Hey. But is this the same room that I entered? Okay, never mind. I think we have the number of people we need. Okay, so this class, to make sure that you're in the right class, even though I was in the wrong lecture, I don't know how I got that link. This class is discrete math. You may ask, what exactly are we learning in this class? You are going to learn essentially a different kind of math, okay? The kind of math that you learned in high school was like, was something I call symbolic manipulation. In this class, you're gonna learn more of reasoning, okay? The thing that we focus on in this class is called mathematical reasoning. Okay, so we're gonna go to it today. But first thing first, let me go to all the class logistics, like how we grade and so on. So this class gonna meet every Tuesday and Thursday, and I checked already. There's no holiday, unless Payut decide to give me some random holiday on Tuesday or Thursday. There's no holiday, so most likely you're gonna meet at every single class, unless I have some other emergencies, then I'll let you know. Okay, it's gonna be 2 p.m. to 4 p.m. Okay, and this class, most of the time you're gonna spend in this class is you're gonna do the homework. Okay, so the homework is going to be weekly. It's going to be weekly, and it's gonna due on Thursday. Okay, every Thursday except this Thursday. Except this Thursday. When is Ajahn Kanat's class due though? The the data structure class, when is his homework due? You guys know? Or you haven't had his class yet? Hello, guys.
I don't think he's released the first assignment yet, Kap, so I'm not sure.
Okay, so but if it clashes with Ajahn Kanat's class and something, let us know. Let one of us know. Then we're gonna figure something out, because I know if this class homework and Ajahn Kanat's class homework due almost at the same time, then you guys are screwed. Okay, we will arrange something. Okay, Thursday at midnight. Okay, the homework, let me emphasize, like Ajahn Kanat's class is the most important aspect of this class. Okay, the homework is actually, I encourage you to collaborate. So that means talk about it, give your friend some idea, but don't spoil your friend though. Don't spoil your friend. Give your friend some idea so he can work it out. You're gonna see once you do the homework, not homework 0, but starting at homework 1, you're gonna see it gets a lot harder. Okay, you need to collaborate. We do have Discord to collaborate if you want. Okay, if you go to Discord channel, there is a channel called Discrete Math Text and Discrete Math Video or something. Then go and talk there and ask there what happens. I also have some TA for this class as well. Okay, I'm gonna let him know to introduce himself in the Discord. So you can ask him about the homework and so on. But homework, like I said, is the most important aspect in this class. You're gonna learn a lot more from homework than from me talking. Okay. So, and then we're gonna have also the exam. We're gonna have 2 exams, which is the midterm and the final. Okay. Each one's gonna be weighted 40% times 2. Okay, and the homework is gonna be weighted 20%. Okay. Any questions so far though for the class statistic, because I want to get it out of the way to be clear. Okay. You probably heard from your senior that this class, the homework is actually pretty hard. So collaborate, and if you have trouble, let us know, because like I said, this class is not the place where I try to measure your IQ. I just want you to learn. I just want you to appreciate reasoning. Okay, it's not really the place where I really want to measure your intelligence or anything. So as long as you learn, no matter how, I'm good. Okay. Any questions though? Any question though? Any question? You guys are awfully quiet. Anyone? Okay, looks good to me, right? So let me repeat that again. The homework due Tuesday and Thursday. No. Class is at Tuesday and Thursday, and the homework is due on Thursday, except this Thursday. Okay, and it's weighted 20%. There are about 10 of them. Okay, there are about 10 of them. And also for midterm and final, it's 40%. If you have the problem with the homework, like Ajahn, I really need 1 day delay or something, let us know. Okay, but I encourage you, don't do that. Don't do that. Try to be on time. So that means what I recommend you to do when you get the homework is, number one, you don't need to do it right away, but at least read the question. Read the question right away. Okay, at least you know what we are asking. Some of the problem will take you a day to think about it, but it takes you like 5 minutes to write down. Okay. So that being said, if you guys have no question, let's get into it. Let's get into it. Okay. Feel free to interrupt me at any time though. Okay. So a large chunk of this class is essentially teach you how to prove. A large chunk, at least a half. Okay. How to prove. Okay. You may ask, okay, exactly. That's not the correct spelling. How to prove. Okay. So the idea here is proving is actually cannot be taught like the mechanics of how to do the integral. Like you have the step-by-step instruction of what to do. So for example, if you try to integral of x squared dx, right? You have the instruction of, okay, Ajahn, that's easy. You move, right? You move 2 in front. No. You increase the power by 1, right? And then take that divide, and then don't forget to add the c. Something like that. That's an instruction. That's a rule, right? So there's a rule. But before you get the rule, you prove the rule first. But there's a rule that you need to manipulate, and then you are graded, or you are expected to be able to follow the rule. But in this class, you should be able to judge whether the rule makes sense or not. Okay. So for example, let me give you some simple example. Okay. The simplest example that I can give you is, can someone give me 3 consecutive number? 3 consecutive number. Anyone? 3 consecutive number. Type in the chat, or you can say it out loud. Wait, I think my chat is frozen. Wait 2 seconds. Is my chat frozen?
I think you're viewing the chat from the previous meeting.
Oh, I'm so sorry. That's why I thought you guys are awfully quiet. Okay, I screw up so many things today. and that will be a day where I forgot to switch the screen and so on. Let me know immediately. Okay, let me answer all the questions that I forgot. Okay. DSA1 is going to be released tomorrow. Okay. What is discrete math? Good question. Discrete math is, if you take it by the name, it means the mathematics of non-continuous variables. So the mathematics of discrete number, like 1, 2, 3, 4, 5. Okay. No participation score. Typically, participation score is for consolation prize. So if I need to, what's that called? if you are like 88 out of 90, then don't worry. Okay. Okay. I opened the wrong chat. That is why. I took calculus 1 2 semesters ago. Would that be a problem? I have a little bit forgotten the formula. That's actually not a problem because not only that I give you formula, the exam's gonna be like, you just do it. You forgot everything related to math. Good. That might be a good thing. That might be a good thing. You forgot everything related to math because you're gonna learn it new. Okay? Because you have never taken Cal 1. Then go take it immediately, like next time or something. But that's okay. This class is not exactly related to Cal 1. Okay? But it's actually good that you forgot about math. Then you're gonna relearn it. Okay? The fact that you relearn it is you're gonna relearn the reasoning. So a lot of people give me a lot of number. So there are people who give me 3, 4, 5. Those are consecutive number, right? Risky, give me that number. 3, 3, 3 are not consecutive number, right? Right. Minus 1, 1, 2, 3 is consecutive number. So let me write that. So there are 3, 4, 5, and there are 7, 8, 9. There are people 1, 2, 3. You are a programmer. You should test the test case, which is the easiest one. Okay. So let me do something simple, like add them up. I'm pretty sure when you say you forgot all about math, you still remember how to add, right? If you don't, there's a Google for you. You can type 3 plus 4 plus 5 in Google and it tells you the answer. It's 21st century, so that's actually okay. So 3 plus 4 is 7, plus 5 is 12. If I do algebra wrong in this class, let me know immediately. So 9 plus 8 is 17, 24, right? And this is 6. Anyone notice something about these numbers? Anyone notice something about these numbers? Okay. Even? The next one is bigger than the previous one. Okay, let me show you some other number. It is even. Okay, good. You notice something. It is even. Okay, so let's try something bigger, like 10, 11, 12, or maybe 100. 100 and, whoops, 101 plus 99. Okay, that's better, right? Multiple of 6. What do we get here? What do I get here? 1033, right? Okay, and this is what? 200, 300. Right? So if you think about it, it's actually not even, right? So very good. You observe some pattern and you should try whether it's true. Okay. Multiple of 6. 33 is not multiple of 6, right? Okay, he said, notice something, right? So all these are multiple of 3. Okay, you notice that multiple of 3. If you want to sound smart at an interview or you want to sound like a mathematician, you say that this is divisible by 3. Okay, you just try to sound smart like a mathematician. You're gonna say it's divisible by 3. Multiple of 3 works too. In this class, I'm not trying to get you to be very rigorous about it, right? So let's think about this. So let's say you observe the following patterns, right? You observe the following pattern. For Saran, I'll get back to that question because of 3 number. Can we just conclude? Can we conclude the following, that because of 1, 2, 3, 4, 5 example that we did, because of 5, that any 3 consecutive number. Okay, let me put sum of any 3 consecutive number is a multiple of 3. Let's say it's divisible by 3. Let me sound like, let me pretend that we learn math. Divisible by 3. Okay, So let me ask you, like you don't know what a proof is for now, right? Let's say you don't know what a proof is for now, but at least tell me honestly, are you happy with the following explanation? Given this theorem, are you happy with the following the following explanation that any number, any three consecutive number, when you add them up, it's going to be divisible by 3 because I tried 5 times? Definitely not, right? If math is the other way, actually, you you think it's wrong until you prove it's correct. Very good. This is the feeling that I want you to get. Okay, a lot of people misunderstand that. Okay, you try couple example, and okay, maybe we can generalize it to a much better theorem. So that also means what if I'm not trying it 5 times, right? We have Python. We can do for loop, and we can try it 5 million times. Is it better? This is a more satisfaction. How many numbers are there? How many numbers are there? How many 3 consecutive numbers are there in the world, in the universe? How many 3 consecutive numbers are there? Infinite, right? You touch only 5 million, right? Out of infinite amount. So if you think about it, you are testing like 0% of all the samples. Okay, that's good. So the fact that this is not a proof doesn't change no matter how much you change the number, unless you know that there are only 5 million number in the world, then yes, you try 5 million of them and it works, then it works, right? But no, there are infinite of them. Okay, so rule number 1 in this class, do not prove by example. That's rule number 1. Okay, that's rule number 1. Okay, that being said, okay, it doesn't mean that trying out some example is a bad idea. It's actually a very good idea. This is actually a very good idea. Try out some example. This is good. Okay, because we want to see how it works. Because we want to see how it works. Okay, any questions so far though? Any questions so far about, okay, I want to show you that do not prove by example. Like if we have this theorem and I say prove it, don't do the following. Don't give me 5 examples and say this theorem is true. Even though it might be true, but this is not a proof, right? It doesn't give you a satisfactory answer, right? A proof is more or less a satisfactory answer. Yeah. So what's a better explanation? I saw someone type something. So now what suggests something really smart? Okay. Now what suggests something really smart? So he says the following. Yes, Ajahn, we cannot enumerate all the 3 consecutive numbers. But what we can do is we can generalize 3 consecutive number, right? We can generalize 3 consecutive number. So now I say the following. Every 3 consecutive number gonna look like the following. Okay? So let's say without loss of generality. This is a mathematical phrase as well. Loss of generality. Okay? Let the 3 consecutive number be, right? If the first number is A, what's the next number? Can anyone tell me? What's the next number? A plus 1, B. Actually, if you guys are in like real class, if you guys in the real class and then you answer, right? And then your answer is funny, then I give you candies as well. You get a prize, but I cannot give you candies online. Even though I can send you sticker, but that is not equivalent to candies. Okay. So I think everyone agree. If you pick any 3 consecutive numbers, right? These 3 consecutive numbers are going to look like A plus 1, A plus 2. Any number, any three consecutive number. Okay, so far so good. Then what? Anyone has a good idea, right? Remember, our goal here is to say that, okay, when we add up, it's divisible by 5. The sum is divisible, well, not by 5, by 3. Group by even odd? What do you mean? Unless you want me to call you by your nickname, though, like tell me your nickname like 3 times, then I probably will remember your nickname. Very good. Josh suggests, how about we say that the sum, right, is divisible by 3. So all we need to do is just add them up, right? Add them up. So we're going to add them up, a plus 1 plus a plus 2. And that becomes 3a's plus 3, right? And Karit and some other people as well suggest that, okay, Ajahn, I can see on the right over here, that, okay, this thing looks like 3 times some number, right? It's a 3 times a plus 1. And then, okay, that means it is divisible by 3 because it's 3 times some number. Okay. Any questions so far, though? Any questions so far? Any questions so far? So if I ask you, like, think about your feeling now versus when I gave you the 5 examples. Okay, I want you to compare that, right? When I gave you the 5 example and I say that the theorem is true, that sound like, that doesn't sound good, right? But if I give you the following explanation, I'm pretty sure you agree with me that this sounds a lot better than the 5 example that I gave you, right? Okay, this sounds a lot better. Okay, so this is the feeling that I want you to get when you prove something, right? Right? It sounds a lot smarter, and it sounds like there is no more question that you can ask. You cannot ask. So for example, for this, the 5 example, you can ask, there's still question to be asked. What about a million and 1, and a million and 2? Do they add up and divide by 3? Right? You still have question here. But when you do this, you don't have question anymore. And if you try to sound like a mathematician, there is the word QED. It means that's all there is to prove in Greek, which I don't know what it stands for. You can look up Wikipedia. Or some people do this. You probably, you should be proud of your proof, and then you put your name there. So in the lecture note, I put a square. That's a standard notation. There are some people who put Batman. I don't know how to draw a Batman, but you get the idea. Something like that. I'm pretty bad at drawing. Or some people draw, say, boom. Something like that. That works too. Okay. So when you're done with the proof, like, sign it with your signature. Although the other lecturer are gonna ask me, why are everyone drawing Batmans on the proof? Then I'll explain to him, don't worry, draw anything you like, you sign your proof. Okay, so far so good. So far so good. Let's do another one. We tried 3 numbers before, and someone asked me earlier, Ajahn, is it because of 3 number? Actually, that's a good question, right? Is it because of a 3 number? How about let's try 4 numbers? Let's try 4 numbers. Can someone give me 4 consecutive numbers? Let's try 4 numbers. 1, 2, 3, 4. You guys are lazy. What about it? 5 plus 5 is 10. Give me like 2 more. Okay. Should I call you Peter or Kwon Chen? Peter is easier to pronounce for me. Peter, okay. Peter suggests something smart. But before we try that, let's try something. Oh, so you guys have the nickname in the middle, right? So Ngan, 11, 22, 33, 44 are not consecutive number. A consecutive number needs to look like this. 10,000 plus 10,001 plus 10,002. Okay. Right. So we add them up, and what do you get? This is 20,000, 30,000, 40,000, and 2. It's okay. Sometimes I thought you were trolling, but that's okay. Trolling is fine in this class. Like Pangamon passed this class already. She's still in this class. She is just trolling. Is she still here? Okay, so let's say if we want to generalize our idea, right? Someone asked me earlier, is because we have 3 consecutive number and it's divisible by 3. And we try 4 consecutive number. Is it divisible by, oops, is it divisible by 4? We try 4 numbers. No, how did you know? How did you know? Airbus and Peter, how did you know? How did you know? It's not divisible by 4. How did you know? Very good. It's clear, right? 10 is not divisible by 4. 40,002 are not divisible by 4, right? So this is the revert, right? We want to say that the following statement is wrong. We want to say that the following statement is wrong. And it's very simple to show it because all you need to do is you just need one counterexample. You don't even need to show that it's wrong. It's not prime, it's even. Only prime number. Let's try. Good idea. Actually, that's partly true, but it's something a little bit better. Right? So let me look at this concept first. So if you want to say that this statement is false, all you need to show is one counterexample. So this is false because 1 plus 2 plus 3 plus 4 is equal to 10, which is not divisible by 4. And then you're done. You sign your name like with a square. Even consecutive number is divisible by 2. Are you sure? Let's try what Saran said. What should I try though? What should I try? Even consecutive number. What's the simplest case? Okay. But that's very good that you're suggesting some idea. You observe some pattern. That's actually what mathematicians do. You observe some pattern and you judge whether it's true or not. Okay. What is the smallest even number? Non-zero. 2, 4, 6, 8 are not consecutive. 2 numbers, right? Let's say I pick me 2 consecutive number, 2 plus 3, something like that, right? So what Saran was suggesting is even consecutive number, is it always divisible by 2? Not really. Not really. Like this guy is 5, right? Then you disprove, right? Okay. So the theorem that say even number sum of even consecutive number is divisible by 2. This is wrong, right? Because we just gave the counterexample. Even amount of consecutive number. Yes, 2 and 3, there are 2 numbers. There are 2 numbers and 2 is even. Right? And they add up to 5, which is not even. So not really, right? Oh, that's fine. Okay, so let's extend this a little bit. Okay, we know 4 doesn't work. How about 5? 5 consecutive number. Give me 5 consecutive number. 1, you guys love this so much. 2, 3, 4, 5. Can someone give me something more fancy? That's the same thing. I just add 500 to the other one, but I can do that as well for you. Oh, wait. That's something a little bit different, right? So 1, 2, 3, 6, 10. So that's 410. Okay, Airbus, now you need to tell me what's the sum of those numbers that you gave me. Okay. And Ngan suggest 995. Help me put that thing in Google or something. 355. Thank you. Ngan, help me. Whatever the number is. What's the number? 4985. Thank you. What do you notice? What do you notice about this? Patty. Okay. Oh, I thought the dash mean Ngan. Sorry, I was stupid. Okay, Patty, sorry about that. I thought the dash after your name was signal your nickname. Okay. So this thing is all divisible by 5, right? Okay, this thing is divisible by 5, but again, you know, this is not a proof, right? We tried 4 example. We were not satisfied with 5 million numbers, so we should not be satisfied with 4 numbers. Okay. So that's good. So they are divisible by 5. And can you prove it? Can you prove it? Okay, Peter suggests the same trick, right? But I'm gonna do something a little bit more fancy. I say that 5 consecutive number looks like this. Then you're gonna see some pattern. Okay, the next one is gonna be a plus 1. The previous one is gonna be a minus 1, and a plus 2, and a minus 2. So we start at a minus 2 instead of a. Right, it simplified my life a little bit. Right, so we claim that all the 5 consecutive number gonna look like this. And do you guys know why I write like this? So this is the first, the second, the third, the fourth, and the fifth. Anyone knows why I do this? Because when you add them up, right? These people cancel out. Oops, no, stop. 2, 2, 1, 1. Okay, they cancel out and they add up to 5a's, which is clearly divisible by 5. Okay, good. Right? So far, what we learned. Any questions so far though? Any questions so far? Sometimes I was into it and then I go a little bit too fast. Any questions so far though? Any questions so far? Okay. Generalizing good. Very good. So far we learned the following. We learned the following, right? We learned the following that divisible if you have 3, it's okay. 4 is not okay. 5 is okay. Do you guys see the pattern? Which is like this is a lousy pattern, right? If you were to generalize this, what would you say? What would you say? Odd amounts only. Okay, Patty suggests 11, 12, 34, 23, and 44. You're not from sign division. Okay, that's interesting. I have a lot of random people taking this class, but that's okay. I used to have business major taking this class and she loves it. Okay. So the consecutive number are the number that right next to each other, right? So 22 is not right next to 11, so they're not consecutive. Okay. 1. So it seems like any odd number of consecutive number. Do 4, 6, 8 are not consecutive as well? No, consecutive means it has to be right next to each other, like 2, 3, 4. 2, then 3, then 4. Okay, any odd number of consecutive numbers. Let's say consecutive integer. That's better. As the sum divisible by. So we want to reuse this. Let's call this n by n. Okay, where n is the same number that you pick. Okay, so this is the true theorem. This is the true theorem that we're not going to prove today, even though I think you know how to prove it, but we're not going to prove today. We're going to prove it maybe next time or next time. Okay, but you can see math. We start from something very simple, like we ask you, what about 3 consecutive number? Then we start observing by, okay, what about if we try 4? Then we try it and fail. Then at least we learn that it fails. We try it again and it works. So now we try to see the pattern. When does it work? When does it not work? Okay, and that's actually what this class is all about. It's about to be able to judge whether something is true or false and to be able to provide a satisfactory answer. That is what we call a proof. Okay. Any questions so far though? Any questions so far? Not today. This is not today. Not today. We do this. Not today. Okay. Any questions so far? I think I need a battery in my 2 seconds. Okay. It is. You will see after you take this class, you know what satisfactory answer means, right? Satisfactory. Yes, that's why I cannot give you the definition of proof, because you can look up Wikipedia. Someone is probably going to give you a definition of what a proof is, but eventually you're going to read it and you have no idea what it means, and then all I can tell you is you know it when you have the proof. That means you have no question left to ask, and that's satisfactory answer. Okay, but to be able to do all that, like you can see, English is bad. English is not the language of mathematics. English is imprecise. English is confusing. It doesn't do better, but any spoken language is bad for mathematics. So the first thing that we need to learn to get out of the way so that we speak the same language is to learn about the notations. Okay, to learn like when I say the following, what exactly do I mean? So let's get it out of the way. Typically, these are something that you might have learned already or you might have not, but that's okay. Okay, so the first thing that we need to learn is the set. Okay, the first thing that I need you to learn is called set. Okay, set is essentially a collection of things. There's actually the true definition of set as well, and there's like a whole bunch of other problems with set. But let's get the general idea. Okay, it's the collection of things, and I'm not even saying what things are. Like, so for example, and we denote the set by the following. So when I say A is a set of 1, 2, and 3. Okay, so it's a collection of these 3 numbers. So that means I can ask you the following. I can ask the following, right? So I know that 1 is in, okay, in that little e over here. Let me write nicely. 1 is in A. Okay, so far so good. So we are learning the notation. All the Greek symbol, the funny symbol that you see. Can set be in any state beside number? Yes, we're gonna do that real quick. It can collect anything. Okay, and also if we say that 4 is not in, so we write like this. This is not in. Oh, it's not in A. Okay, so far so good. You can call it that. You can call it the set of items on your table. That works too. Okay, that's a good question. But before that, let me do another one. Let me do another one, the other notation, which is this thing means the size of A. Size of A. Or some people call it the cardinality of A. If you want to sound like a mathematician, use like fancy word. Cardinality of A. Okay. So it's essentially all you need to do is like count. So there are 3 numbers. Okay, so that's good. We're going slow. And Saran asked a very good question. And Bomb too asked a very good question that can everything else be in the set? Yes, you can make the following. You can make B as a set of, I don't know, a dog, a cat, and a bird. Okay. Or you can say that C is a set of the programming language you learn, Python, C, and Java. Let's say you learn these 3 languages, and you can have more than 3 as well. What else? Scala. Good question. You can make it. You can do that as well. You can make a set inside a set. Like 1, 2, 3, 4, 5, 6. But we typically don't get there. But yes, you can have a set inside a set, and that creates a whole bunch of problems. Right? You can even contain object. Right? You can even contain object. Okay. The set can contain set, but here is one special set. This is called empty set. It means it's a collection of nothing. There's nothing in there. This is pretty useful. This is pretty useful to define that there's a set, there's a collection of nothing in there. Empty set, some people write it like this, phi. Okay, you are just learning a whole bunch of patterns. Every set have empty set. I know what you meant, but no, you have the right idea. We don't call it the set in the set. Okay, so let's do this. Okay. Any questions so far though, before I get to some question? Any questions so far? Okay, you probably see this before. You're just seeing a lot of Greek symbols. You're seeing like, why do you put a bracelet there? Why do you put like that little E over here? What is this phi and what is this absolute on the set? Okay. So we can do the following. There are some set operation that we can do. Okay. There are a lot of operation, but the most common two are union. Okay, union, that means, so let's say if I have set A, is I know 1, 2, 3. 1, 2, 3. And set B is 3, 4, and 5. When I say I call A union B, what I do, I just take every single element that appears in A and B. Okay, so that is 1, 2, 3, 4, 5. I want you to notice I only take 3 one time, right? The thing about set is no duplicate. Okay, because you can ask whether something is inside the set or something is not inside the set. So that's good, right? Pretty intuitive, right? And the notation we use that's that little u over here. Okay, the notation we use for union is that little u. And we also have the intersection. So for example, A intersect with B. So this symbol means intersect. Okay, so classical. And what we do is we just take the common element, which is this guy and that guy. Why is it all pastel color? Yeah, pastel looks nice. So A intersect B, that's gonna give you the set that has one element, which is 3. It doesn't give you 3 though. It's a set that contains one element, which is 3. Yeah. So there's one case that you might need to be a bit worried about, which is what if C is like 7 and 8? Okay. Then if you look at A intersect with C, right? There is no intersection. There's no common elements A and C, right? There's no common element. So that's why we say that it is an empty set, or sometimes we call it the empty set. Okay. Any questions so far though? We are learning just a whole bunch of like weird symbols. Any questions? This sounds simple, right? This sounds very simple. So, but still, again, I introduced it to you today so I can get it out of the way. But when we do the actual class, the actual proof, and I wrote something that you have no idea what it means, just ask me to clarify. Okay? Just ask me to clarify. Okay. So another thing that we also are interested in is proposition. It's something called proposition. Okay, or the stuff that we want to prove, right? So for example, are the sum of 3 consecutive number divisible by 3? That is something we can prove, right? Are the sum of 4 consecutive number divisible by 4? That is something we can show whether it's true or false. But there are some questions that we are not exactly interested in this class. So for example, the question that we are not interested in this class is, what did you have for lunch? Right? So there are, let's say, sum of 3 consecutive number is divisible by 3. Why? Risky, eat something. My class is at 2 p.m. You should be able to eat something by now. Okay, so there are some things. So for example, it doesn't have to be mathematics. So for example, there are 34 people in this class. Okay, good. That's a good question, but I like the lunch one better. Okay, what did we have for lunch? Or if you guys are old enough, what's the answer to the universe? Very good. Let's see. You guys are old enough. It's a good movie. If you never watch it, watch it. Hitchhiker Guide to the Galaxy. Is it on Netflix? I don't think so, right? It's too old. You read the book. Come on. It's a good book. It's a good book. For those of you who have no idea what we are talking about, yes, there's a movie. It's very good too. Go watch it. Go watch it. For those of you who are in 21st century and hate to read books. Someone type it, Hitchhiker Guide to the Galaxy. So you can see the difference, right? You can see the difference. There are two kinds of questions. There are these questions. We call this proposition because it's either true or false, right? It's still very good movie. You can watch it like in 2021. It's a very good movie. If Netflix doesn't have it, I cannot tell you where to get it, but I know you can get it. Okay, so these are not proposition because the answer are not true or false. Not true nor false. There are also some logical problem that's, can I watch it right now? You know, there are people who do like random things in my class. The worst case was playing poker, which I let him do it anyway. So if you went to MUIC computer lab, there some class we don't have that many students, right? So you can have 3 screens. So this student, he played pokers on one screen, play stock on another screen, and the other screen, I think it was a YouTube. But that's fine. That's fine because when I was a student, I did it exactly what you did. But I don't recommend it, but I cannot force you to not do it. Okay, so let's go back to the math. What we want to learn, all right? What we want to answer, we want to decide whether the proposition is true or false. So the proposition has to be something that is true or false at the very beginning, right? So these questions like, what did you have for lunch and what is the answer to the universe? Those are not true or false questions. We cannot, it is not a proposition, okay? So far so good. When I say proposition, it means it has to be true or false. Right? So for example, the question that Nawat asked, can you watch a movie right now? Yes. So yes, it's not true, by the way. So yes, it's not true. If you change the question to I am watching it right now, then that's either true or false, right? You either watch it or you don't watch it. But if you say, can I watch it right now? The answer is yes, it's not true. Not false. Okay, so far so good. So far so good. If we extend this idea, let's go one more time. Let's go. If we extend this idea a little bit, right? We can change this number, right? So we can change this to number n, right? So there is another thing that is called the predicate. Okay, the predicate is the proposition that depends on the number that you put in. So for example, if I just change this statement, how do I paste this? So if I change this statement to sum of n consecutive number, okay, the predicate is you can think about as a function that you take in one number and it's returned true or false. Okay, a predicate looks like that. So we know this statement is true for some n and it's false for some n, right? Right. So this clearly true for some n, false for some. So when I say predicate, it just means that it's just the function that you put in the number and test whether the statement is true or false. Okay. And you may ask, okay, how do we get to use this? The following is the following. So we can start saying things like, so for example, we can start saying things like the set of some number x in some set in integer. Let's say you are say that it's a set of x that is an integer where Yes, we're gonna take a break right after this one. We're gonna take a break right after this one. We will take 10 minutes break right after this one. Okay. The set of x integer where, I don't know, x squared is less than, I don't know, 5. Okay. So let's think about this. This thing is a predicate, right? The thing on the right has the truth value depending on x. Okay. And when we write the set like this, it means that we are taking all the integers. That makes the right-hand side correct, right? So we guarantee that every member of this set, let's call it set A, every member of this set is guaranteed to have this property that x squared is less than 5, or this thing you can write it down as well. So it's going to be -2, -1, 0, 1, and 2. So that I means integer. Okay. So that's good. So this thing is the predicate. Yes, it's very, very similar. Okay. Or we can do something more fancy, right? So it's going to be a set of all the positive integer where sum of n consecutive number is divisible by n. Okay, something as fancy as that. Any questions so far, though? Any questions so far? Okay, so we learned a couple things about the notation that we're going to use in this class, right? We can write a set in many ways. Okay. And we learn that we are interested in proposition, and sometimes we do the predicate because we just need it. Any questions so far, though? Any questions so far? If not, let's take 10 minutes break. Okay. And we're going to come back at 15:11, right? Find my mouse. Where's my mouse? Okay, I guess everyone is back. Okay, so the so we learned so far about the predicate, right? That predicate is a proposition that the truth value depends on n, or depends on some variable. Okay, it's a function that returns a boolean. So for example, let me make sure you know the following. You guys know what a prime number is, right? So for example, we know that 2 is a prime, 3 is a prime, 4 is not a prime number, because 4 is 2 times 2. So prime number has to be divisible by only by itself and 1. Okay, 5 is a prime number, 6 is not a prime number because it's 3 times 2. 7 is a prime number, 8 is not, this is 4 times 2, right? And 9 is also not, so this is 3 by 3. So it's not all odd numbers. And the quest to like generate all the prime number has a very important very important application in today's life. All the cryptographic are based on, most of them are based on the property of prime numbers. Okay, so let's do the following. Okay, so I claim the following. We kind of have some idea what a prime number is. So let me claim the following, that, okay, I say that give me any n, okay, n square plus n plus 41 is a prime number. Okay, I claim. This is the theorem. Okay. This looks hard, right? This looks hard. We don't even have a good idea whether this thing is true or not. What should we do? What should we do? Anyone has a good suggestion? What should we do? Brute force? Good idea. Let's do that. Let's do that. Good idea. You should think like a computer scientist, right? Find n. There's no equal on the other side, so you cannot find n, right? There's no equal on the other side, so you cannot find n. Okay, you think like computer scientists, you brute force. Yes, you have computer for a reason, right? At least like when you try to find example, you at least get your computer to do it. So let's say n equals to 1. That's not 0. So I say that when n is equal to 1, I plug that thing in, right? It's become 1 plus 41, which is 43, which, trust me, is a prime number. Or you can actually go to a website. I think there's a website, something called "Is it a prime number?" and then you can enter the number and then say yes or no. But you know, you probably did programming one, how to find a prime number or something along that line. Okay, but 43 is a prime. Let's try n equal to 2. Let's do exactly what Bomb was suggesting. Okay. Okay, so that's a 2 square plus 2 plus 41. So that is what? 4 plus 2, that's 6, that's 47. Okay, that looks good, right? We are like 2 consecutive number already. N equal to 3 n square. So that's 3 square plus 3 plus 41. This is 9 plus 3 is what? 12. And that's 53. That looks good, right? Still a prime number. What about 10? What about 10? Let's go crazy. Let's go crazy. 10, you get 100 plus 10 plus 41, right? This is 151, which is still a prime number. You can test it. Okay. What do you think? What do you think? Is this true? What do you think? Is this true? Negative number next. Now, let's put here f for positive for n in I plus. It's true then. What the bomb said is true. So you can see that you try all the things that is still true. We know by now, right? This is not a satisfactory answer. You have a spoiler. I think it's a good time for spoiler. Tell me, spoiler, Alexei. Very good. Alexei say, okay, I try. At least you probably write Python before. So you put in 41 square plus 41 plus 41. How do you know that this thing is not a prime though? How do you know this is not a prime? Not your answer. I watched it from MIT lecture course because this is a very famous problem though. This is a very famous problem. And also in this class, you're welcome. You're more than happy to, you're more than welcome to go watch MIT lecture course. It's really good. It's really good. A lot of my class, a lot of things I do in class is based on MIT lecture course. It's really good. The lecturer, I don't know what his name is, but he's good. What is 41? That's 42. I think it's 42, not 41. Okay, but you can see this thing is not a prime. Just search MIT discrete math or something. It's really good. And also he has a really good lecture notes as well. You can go read it. Okay, so let's do this. Okay. So we know that this is false, but it is a very famous problem to give to like first or second year student to know that even if you try 40 numbers and it doesn't work, that doesn't mean that this thing is true, right? Okay, so but what I'm trying to get at is the following. This proposition has two parts. Okay. Okay. This proposition has two parts. It has the predicate. Okay. The thing that we want and the thing that we want to quantify. That means is this state the statement is true for all n, right? So this thing is called a quantifier. If you go to his actual website, there's a lecture notes as well. Okay, so far so good. And okay, so we have another piece of puzzle that we need to learn. It's called a quantifier. Okay, so let me give you an example. So when I say that n squared plus n plus 41 is a prime for all number n in integer. Okay, this thing is false, right? And we have a symbol for that. The symbol for this is the following: n squared plus n plus 41 is a prime for all. This upside down a means for all. This thing and that thing means the same thing. Okay, because we use it a lot, we have a symbol for that. Okay, and again, this thing is false. Okay, but if I claim the following: n squared plus n plus 41 is a prime.
Search anyone's full name, you get their email.
What's up, Pankamon? You forgot to mute. For n, not for n.
Solve some form. Thank you very much.
For some n in integer.
You were probably the only one here who hasn't. I mean, here as in this group chat. Bigger room.
What about it, Pankamon? I'll mute you. What about it? I think she forgot to mute, right? Let me mute you.
I'm on turn also. Yes, please do light OJ. Thank you.
Okay. So n squared plus n plus 41 is a prime for some n. So that means there exists, or we write this mathematically, we do the following. Okay. This little symbol, this like mirror E, is means for some. or some people call this diaresis. Okay. If your theorem say, find me some number, oops, find me some number that when I put it in to the left, right? That when I put it in on the left and it makes it true. Okay. So this statement is true, right? Because for example, 1 square plus 1 plus 41 is prime. Okay. Everyone got the idea, right? So not only that we have the predicate, you need to be a little bit careful about the quantifier, but it's probably pretty clear when I wrote it down. Well, which one I meant. Okay. The same predicate, but different quantifier gives you different results. So that's something you need to be aware of. Okay. Any questions so far though? If not, let's look at another one. Let's look at another one. Another one is called Euler conjecture. Okay. So Euler conjecture starts from something like this. So for example, you have seen Pythagoras theorem, right? A square plus b square is c square. You probably did that before, right? And you know, there are some number, some integer that you can plug it in and it works out great, right? Or maybe 7 and 12, 15 or something. I don't remember that there's some set of number that it works. So he starts questioning. What about if I go something to the extreme? A square plus b square plus c square plus d square equals to e square. Okay. Has no positive integer solution. You can try. It's actually pretty hard. Okay. This is what Euler was thinking. If you don't know the guy named Euler, this is like whole like world record on the number of mathematical theorem he wrote, I think. Don't quote me on this. I think one of the smartest mathematician there was. Okay. He was, don't quote me on this as well. I think he was about 200 or 300 years ago. And conjecture means this guy, really smart guy, Euler guy, has no idea whether it's true or false. Okay. But he thinks it's true. He believes it's true. It's true, but he can't prove it. Okay. But what we are trying to do now is I want to try to teach you how to write this guy as mathematical statement. Let's use all the symbol that we learned so far to write this statement in a mathematically precise way. Okay. Okay. And the way to do that, let me get to that real quick because we kind of run out of time. The way we do that, I want you to see that these two are equivalent. Okay. A square plus b square plus c square plus d square is not equal to e square for all a, b, c, d, and e in I plus. Okay. What it says is the following, that you can try all you want with these numbers, right? All the integer, all the combination of integers you can try. You can plug it in on the left and it's still not going to be equal. So these two statements are exactly the same thing. Okay. I want to show you this. Okay. Any questions so far though? Any questions so far? I want you to see that these two statements are equivalent. You're going to get to do some exercise in the homework as well. But let us take a vote. What do you think? Is this true? What do you think? Let's see how democracy works in Thailand. What? No. E is an integer. E is not 2.7. E is some integer. So you can try. So for example, these has to be all integers, right? 3, 4, and 5. So you can try all the integers. What do you think? May you remind the flip A means for all, for all. For all. Does it mean for all? For all. That means pick any integer you like, plug it in on the left, and it's still not going to be equal. Okay. And this thing turns out right. Right. So if you try to show that this thing is false, all you need to do is something very simple, right? All you need to do is find A, B, C, D, and E from me, and then I believe you. Right? You need to find A, B, C, D, and E. Right? And then plug it in on the left, and oh wait, they are equal. Then my statement would be wrong. Right? My statement would be wrong. I want to show you something. How do I share the screen? I can switch my OBS to full screen. Wait a second, full screen. Which screen is this? Okay, the correct screen. Okay, so this is actually one of the shortest paper. Okay, this is one of the shortest paper. Wait. You said something. Wait, just a minute, Ajahn. Yeah, I'll just trying some number. This is the shortest paper. But so this guy, about 1966, so about 200 years after Euler's death, he found the following on a direct search on CDC 6600. What that means is that he ran for loop. That's all he did. That means this guy, these two people ran for loop and found that, okay, this number are equal to the other number. Done. Boom. Right. And then that's it. So this is the shortest paper I think I have seen. But think about this. You need to wait 200 years. You need to wait 200 years until the invention of computer before you can actually solve this. So nowadays you can write this in Python. This is you. I'm not sure, Alexei. Try tonight. Try write a program to find this number tonight. You need to write it pretty well, otherwise it's going to take a while. In C, it takes like 0 time. Yes, that's the whole paper. If you're really cool, then you can do it, right? Well, that's all there is to say, is right? That's all there is to say. Actually, you can write it tonight. It probably takes you 20 minutes. It's even easier than Ajahn Kanat's homework. You can do it. Probably as easy as programming one homework. You probably don't know by now. If you go back and do programming one homework now, you're gonna find it's like, why would I waste time on this? It was so easy. Why did I think about it for so long? Okay. You can do it tonight. You can do it tonight. Find this number. Distinct integer. I think the fact that you make it distinct doesn't really help. Or non-distinct doesn't really make it the problem easier or harder. Okay, you can try it tonight. There are some other numbers as well. It's a little bit bigger, but there are some other numbers. Okay, what was I trying to do? Okay. So we learned something about quantifier and we have fun with it, right? So another thing that I want to warn you is the following. You can mix the quantifier. Okay. So quantifier mixing. And this typically gives you a lot of trouble because you're like, come on, what does it mean? Okay. So for example, I claim the following. For all integer x, okay, this is for all, that upside down a is for all integer x. There exists a y such that x plus y is equal to 1. Okay, let me put in integer. This thing includes negative as well. When I write just integer without the plus, it means all the integers. Okay, so there exists a y in integer such that x plus y is 1. What do you think? Is this true? That means for all x, there is a y that match with it, and you add them up, and it gets up to 1. What do you think? Is this true? It's true, right? So for example, if let's do some example to make sure everyone understand the idea. So give me any x. So let's say I give you 5. Your job is to find y such that add to 5 is minus 1. So then you can find, okay, done. That's easy. Y is minus 6 because when they add them up, oops, not minus 6, minus 4. Minus 4 because when they add them up, it adds up to 1. Okay, sounds good, right? So if I give you x is 10, then y is minus 9, that's all. Okay, so far so good. Or in general, if you try to prove this, you say that without loss generality, let's give an x, y is equal to 1 minus x, that's all. Oh, sorry about that, Airbus. Thank you. This is such that, because we gonna use it a lot, so I abbreviate it with ST. Such that. Sorry about that. Okay. So it's saying that for every single x, you can find a y. Okay. Such that x plus y is 1. Okay. Let me oh, not COVID though, just water. I got swapped too many times already. So the other one is, what if I just switch the two, right? I just write this. There exists a y such that x plus y is 1 for all. Right. So that E means there exists, or sometimes we call for some. It means the same thing. Okay. So I switch these two a little bit. Okay. I say that there exists a y, a very special y, such that x plus y is 1 for all x in integer. So that's okay. Right? If you think about it, these two statements, you feel that they are a little bit different, right? Even though I reuse all the symbol, I just switched two, right? I reuse all the symbol. I just switched the two. I just switched this guy and that guy. Okay. So the statement below here says there is a very special y such that when you add to any number x, it's going to give you 1. That very special y. Okay. That one y has to work for all x. Is this true? Not true, right? Okay. Right, there isn't such a number because if you change x, then x plus y change. That's essentially the idea. If you change x plus y change, done. So if it was 1 before, it's not going to be 1 when you give it another number. Okay, so far so good. I want you to be careful when you have the mix of the quantifier, then you need to be a little bit careful about the order, unless it's clear. Okay, typically it's clear. This is like edge cases. Okay, these two are different. Any questions so far though? Any question? This can be a little bit confusing. So when you use a quantifier, be careful about the order. Okay. Any questions so far though? What's the difference between? You can act, some mathematician you write this thing the following, but it looks a little bit more confusing. I wrote it down so that you can read it more like English, right? There exists y in integer. Is there a abbreviation for without loss of generality? Some people do the following, WLOG, without loss of generality. Okay, so let's answer Peter. The reason that I do this is because you can read it now like in English, right? So there exists a y in integer such that x plus y is 1 for every x in integer. Okay. Or you can write like this as well. There exists a y in integer such that for all x in I, x plus y is 1. Right? When you read it, it's a little bit more confusing than the top one. I think the top one is easier to read. There exists a y, a very special y. Okay. Let me give you a better example. Let me give you a better example. Okay, good. Okay, so let's say the following example. Let's say in this class, there's a girl and there's some boy and some girls, right? There's some boy and some girl. Which one should we use? The one that sounds correct, the one that's the correct one, the one that is what you want. Okay, so let's say, so this room has some girls and has some boy. Okay, there are two statements. Okay. There are two statements. Okay, you get used to it. This is the first class. You get used to it. So the statements, the first statement say, okay, every boy, right? For all boy, right? There exists a girl in G that B likes G. Okay, so far so good. Okay. So there exists for every boy, there's a girl he likes. That's all it says. Right? For every boy, there's exists a girl that he likes. Okay. This is not the same thing as the following statement. The following statement is there exists a girl such that for all boy, B likes G. Okay. This thing means everyone has to go and like this girl, the special girl. Right? So if the graph looks like this, so if the graph looks like this girl like that, this boy like that girl. So it's gonna be true. The first one is true, right? Because given any boy, I can find a girl he likes. So that girl. Given this boy, I can find this girl. Given this boy, I can find this girl. Given this boy, I can find this girl. Right? But for this case, for the second case to be true, right? There exists a girl such that every boy likes her. Okay? Which means the following. If you look at the top here, there's no girl that every boy is like. So what you were looking at is the following. You want to have this girl where every boy is like her. That single girl, that's G2 as well. Right? So this girl doesn't have anyone like her, but this girl has everyone likes her. So this will make that thing true. This is what you are looking for the second statement, right? There is just a girl such that everybody likes her. So you're looking for this, but the top picture doesn't have this girl. You can ask it outside the class. Don't ask me though. Because it's read fine without such that. You can put such that though. You typically put such that over here, right? Don't worry too much about the details. So as long as it reads like the correct thing, it is correct. Yeah, so that's good. All I'm saying is that you just need to be careful. Drop this class. No, Paddy, don't go yet. You have one more day, right? To drop this class. Any questions so far though? Any questions so far? Any question? Why is the second one false? So it's not false. It say that you are looking for a situation that looks like this. And the situation, if the actual situation look like the top, then you are not, this is not correct. If the situation looks like the one on the top, you're looking for this, you can't find it on the top. Okay. So that's why I say that this thing is a little bit, I don't know, up to you. This thing might be a little bit easier to understand. Okay. So we are finding a special y such that when you add it to the number, right, to every single number, it's give you one, which there doesn't exist one. Okay, any questions for today though? Before we go, let me make sure the following. Let me make sure you can find your homework. Switch the screen real quick. Full screen. And okay, on Canvas. On Canvas, there is a whole bunch of, you can find the homework under file. File, where's the file? Okay, file, and the homework files is here, and the homework is here. Okay, you can find the homework, and the first homework is homework 0. First homework is homework 0. So the way you do it is you have two choices. Either you type it down or you write it in a paper, or you can use iPad to write it as well. But you need to submit it in PDF, okay, because it's online. But even if it's not online, then you need to submit it in PDF anyway. Okay, write all the answer, then upload it on Canvas, which I'm pretty sure by now you know how to upload on Canvas. Yeah. Any questions though for the homework? So the homework 0 is still pretty easy though. It's quite simple. It just tests your knowledge a little bit. But homework 1 gets much harder. Homework 1 gets much harder. Any question though on the class logistic? I'm trying to make sure that you can find your homework. It's due next Thursday. Yes. What's Elon's son's name? I don't know. I don't know how to read it as well. So all boys have some girl they like, or all boy like some girl. Typically, we don't saw all boy like some girl, right? Every boy like some girl. When is homework 1 due? Whatever it says on Canvas, I think I adjusted the due date already, unless I put the year in wrong. Did I screw up? So it's typically every Thursday. So every Thursday, except this Thursday. So the homework 0 due next Thursday. Is there a recommended book for this course? Yes, I think I put a syllabus somewhere. I think it's in the file. Sorry about it. There is also a lecture notes. And there is a whole bunch of book I recommend. Where did I put it? Okay, I'll put it on announcement then, but yes, I put it on announcement then. I put it on home, not even announcement. Yeah. So essentially, you Google the word discrete math and MIT. That book is good. That book is really good. There are so many simple. You get used to it. Don't worry if you don't memorize all this. I'm not asking you to memorize anything in this class. Okay, so you get used to it when you use more of it. Okay. If there's no question, we're gonna call it a day. And it's a machine learning open Excel. Most likely, I think so. If because given there are so many demands, most likely you have small brain. That is, I think. I think you have a big brain, but you just use it for something else. Where can I join on the Discord? Someone send him the link. Where's the link? It's a link somewhere. Where's the link? Oh, there. Invite people and copy button. Paste. Okay, there. Wait, what? That's why is it? It's wait. That's generic link, right? You can use copy button, but I use it already. Okay, good. Okay, someone will send you the link eventually. Thank you. Okay, join Discord. People like put jokes all the time. There is even a meme board, right? Which I'm pretty sure your favorite one. And there's a gaming board. You can stream games. Someone's gonna watch you anyway. Some people stream game. Okay, so let's call it a day. And thank you very much for today. And see you on Thursday. Okay, bye everyone.
Thank you for the class, Ajan.
Thank you ครับ
Bye.
อาจารย์ when will you upload the lecture when
Soon.
will it be up
If it doesn't show up, keep reminding me.
Ajahn, we have assignment right now.
You have what?
Do we have assignment right now?
You will have a diamond? What do you mean? Do you have assignment? You mean that?
Does this class have assignment right now?
Yes, it's due next Thursday. You manage your time yourself.
Where
Do
is
we-
the assignment?
The assignment is under on Canvas, under file,
Oh, file.
and then the file is in the homework section.
it's due next Thursday right อาจารย์ not this Thursday
Not this Thursday. This Thursday, they probably are not done registering yet.
I see โอเคครับ thank you
Any more questions? Okay, let's call it a day. And 2 months.